Today, we are pulling back the curtain on a hidden world of biological espionage. It's happening all around us, on a scale that's just too small to see. It's a high-stakes drama of survival and manipulation, where a tiny parasite literally takes control of its host to pull off one of the most notorious life cycles on the planet, the spread of malaria.
So let's just dive right in with a question that seems, well, pretty simple. When a mosquito bites you, is it making its own decision? Is it in control? You might think so, but the answer is way more complex and honestly a little bit creepy. Because inside many of these mosquitoes, there is a microscopic puppeteer pulling the strings. We're talking about the malaria parasite Plasmodium. And it doesn't just hitch a ride, oh no. It actively seizes the controls of its mosquito host, manipulating its body, its instincts, its behavior, all to make sure it gets to its next victim. This isn't just a passenger. This is a full-on hijacking.
So, how does a hijacking like this even begin?
Well, the parasite's master plan actually starts before it even gets inside the mosquito. See, first, it has to guarantee it gets picked up from an infected person. And to do that, it sends out a very specific and, for a mosquito, an absolutely irresistible invitation. The key to this whole operation comes down to these things called gametocytes. Think of them as the sexual stage of the malaria parasite. Now, other forms of the parasite are what make people sick, but only the gametocytes can actually infect a mosquito and keep the cycle going. So the parasite's entire future depends on a female Anopheles mosquito taking a blood meal that's full of these specific cells.
So how does it make sure it gets that ride? It manipulates the human. It's incredible. Research has shown that a malaria infection literally changes a person's body odor. The parasite makes the human body release these specific airborne molecules that act like an irresistible perfume to mosquitoes. And here's the kicker. This effect is strongest at the exact time those transmissible gametocytes are at their peak in the person's blood. The parasite basically turns its host into a giant, flashing neon sign that says, "Bite me."
Okay, so the parasite gets ingested. Success! But its journey is far from over. In fact, it has just entered the single most dangerous phase of its life. The inside of a mosquito's gut is an incredibly hostile place, and this is where the parasite's survival is truly put to the test. To put this in perspective, a mosquito might slurp up about 1,000 gametocytes in one go. Now, that sounds like a lot, right? But for the parasite, this is the start of a massive population bottleneck. Very, very few of them are going to survive what happens next. For any of them to have a chance, they have to pull off this insane, multi-stage transformation. It's a race against the clock. They have to fuse together, become mobile, and then physically burrow through the mosquito's tough gut wall to form these little protective cysts. Inside those cysts, they multiply like crazy, eventually unleashing thousands of the final infectious form, the sporozoites, which then have to make their way all the way to the salivary glands. This whole process takes about 2 weeks, and it is a battle every step of the way.
And the mosquito is fighting back the entire time. Its gut is flooded with digestive enzymes trying to dissolve the parasites. The gut wall itself is a serious physical barrier. And maybe the biggest threat of all is the mosquito's immune system, which is actively hunting down these invaders and trying to trap and destroy them. But here's where it gets wild. The parasite isn't just a passive victim. It has its own counter moves. It actively suppresses the mosquito's immune system, releasing molecules that basically jam the mosquito's internal alarm bells. It's this incredible act of microscopic warfare, all to clear a path for its own survival.
And this just shows you how brutal that fight really is. Remember that 1,000 or so gametocytes that started the journey? Well, after that initial struggle, maybe only 100 successfully form those cysts on the gut wall. The rest are just gone. But for the survivors, the real manipulation is just about to begin. Okay, this is where the mind control really kicks into high gear. Now that the parasite is established and developing, it has 2 goals. First, make sure the mosquito lives long enough for the parasite to fully mature. And second, make damn sure the mosquito passes it on. And to do that, it hijacks the mosquito's most fundamental behaviors. And it does it with this brilliant 2-phase manipulation. Check this out. While the parasite is still developing in those cysts on the gut wall, when it's vulnerable and not yet transmissible, it actually decreases the mosquito's desire to feed. It makes the mosquito shy, more cautious, less likely to take risks. Why? To protect its investment. But once the parasite matures and thousands of sporozoites flood the salivary glands, it flips a switch. Suddenly, the mosquito's urge to feed goes through the roof. It becomes more aggressive, more persistent, and it's more likely to bite multiple people. It's a perfectly timed, sinister strategy to maximize its chances of spreading. And look, this isn't just some wild speculation. A landmark study basically confirmed it, saying that this isn't just a random side effect of the mosquito being sick. No, this is an active manipulation by the parasite, a trait it evolved for one reason and one reason only, to boost its own transmission. Now, this whole incredible process is a very delicate dance. The parasite's success is never guaranteed. It's all part of a much bigger, constantly evolving arms race between the parasite, the mosquito, and the world they live in. So let's bring back a term I mentioned earlier, vector competence. It's the scientific way of asking, how good is this specific mosquito at actually getting infected and passing on the disease? Because not all mosquitoes are created equal. Their ability to be manipulated and to transmit malaria can vary wildly from one bug to the next. So what makes the difference? Well, it's a complicated recipe. Genetics play a huge part. Some mosquitoes are just naturally born more resistant. The environment is also absolutely critical. Things like temperature can speed up or totally stall the parasite's development. And one of the most fascinating factors is the microbiota, the bacteria living inside the mosquito's gut. Some of these bacteria can actually help the parasite, while others attack it, directly changing the outcome of the infection. What we're really seeing here isn't just a simple infection. It's this deep, intricate relationship that's been forged over millions of years of coevolution. The parasite evolves new tricks to manipulate its host, and the host evolves new defenses to fight back. It is a constant, high-stakes evolutionary battle playing out on a microscopic scale. And that really leaves us with a final, mind-bending thought. This whole incredible story of mind control is happening inside a tiny mosquito. It makes you wonder, what other invisible manipulations are out there, quietly pulling the strings and shaping the spread of diseases in ways we're only just beginning to imagine?